Hey, Miss Writing, this is my manipulatives project by Morgan Atkinson. The first manipulative I chose to talk about was the pattern blocks. What are pattern blocks and how are they used? So pattern blocks are used to teach students. They're good at instilling creativity. They help students to identify patterns, and they help students learn fractions, parts, and even whole numbers. That's where I found them especially helpful, was in learning fractions and learning how to add and subtract fractions. I thought they made that very easy. So how to solve a problem using pattern blocks. Alright, so the shape below, right here, it's one whole. When you divide it up into parts, what fraction of the whole is made up of triangles? So we have 7 triangles out of a 12-piece whole, and that makes 7/12 of the whole. So the triangles make up a total of 7/12 of the whole. Next is the Arkansas State Standards. It's Arkansas Math Content for NFC 5. It's to express a fraction with denominator 10 as an equivalent with denominator 100, and use this technique to add 2 fractions with respective denominators 10 and 100, and this can be applied to different types of fractions as well. Examples of the pattern block problems, as you can see, I'm sorry, I don't remember the name of this shape, but it's one whole. And then the red shape identifies half of the whole, the blue is a third, and the green, which is the triangle, identifies a sixth. And below we have math problems, so a half plus a third plus a sixth equals the whole. And then we have some other examples. So in the above figure we see what is equivalent to one whole. Then the problem breaks down the whole into parts, creating fractions. This is a visual representation, how much of the whole is missing. This is the whole, and this is what we have, 3/4 of the whole. Then 1/4 of the whole is missing, that's 25% of the whole. Next is number line manipulatives. What is a number line and how is it used? Number lines are used for adding and subtracting. It is a line with tick marks anywhere from 0 to infinity. How to solve a problem using a math line or a number line. Count the tick marks on the line. Let's say they are numbered 1 to 10. Starting at 0, hopping over to 3, that's what? 0 plus 3 using the number line. So the answer would therefore be 3. Then say we make an additional line hopping from 3 to 7. What is 3 plus 4? It's 7. So there are 2 number lines, or 2 lines adding up to 7. The first line adds up to 3, the second line adds up to 4. Both together make 7. The Arkansas State Standards, Arkansas Math Content 1OAB3, apply properties of operations as strategies to add and subtract. These are some examples of number line problems. So we have 6 plus 5 equals 11. On the top we see the red line hops over to 6 and the green line hops over 5, so that adds up to be 11. And then there's an equation on the bottom that's not answered, but it hops over from 0 to 3, so it's 1 plus 1 plus 1, which equals 3. And then a visual representation hopping over 2, 1 plus 1, 0 plus 2 equals 2. Next is base blocks. Base blocks are personally my favorite. I think they're one of the most fun things kids get to use in school. What are base blocks used for? Base blocks are made to teach basic numbers that represent ones, tens, hundreds, and even thousands. They are especially good for teaching young children their basic additional skills, and it gives them a good visual, and it's good for hands-on learning. How do you teach base blocks? First, you need to know your numbers. So right here, that's a set of 100, a set of tens, and a set of ones. The single blocks each equal 1. The 10 set blocks each represent 10. The square sets are 100. The problem below is 4 hundreds plus 3 tens plus 2 ones. How much is that? It's 432. The Arkansas State Standards, Arkansas Math Content 1 NBT A1. Count to 120 starting at any number less than 120. In this range, read and write numerals and represent a number of objects with a written numeral. these are two examples of base block patterns. This first one, we see a set of 100 tens and ones. That's 125. A second set of 100 tens and ones. That one is 137, and then we go over here and we use the thousands blocks. And then we also use the ones. So that's 4,002. And then a visual representation. Right here we have 300 blocks. And then we have the two sets of 100 and 610, so that's 260 blocks. And then this one from the previous presentation as well. And that is all of my presentation. Thank you so much. I've also submitted a PDF along with this video. Thank you.